Let's make some rigging scripts that we can help out our rigging workflow. So let's say that I want to make a joint in the middle of this edge loop right here. So normally what you would do is you would go into, rigging, and then you go to cluster. So make a cluster there, and then I press create joint, and I can create joint exactly on that cluster. Go into the outliner, and then I delete the cluster. So what I'm left with is a joint that's right in the middle of this edge loop. But what if I want to just make it with one button? I just click the edge loop like that, and I just say, okay, make a joint right there. Well, let's do a little bit of scripting, and then we will show you how to do that. So first we're going to import Maya commands as CMDS. That's basically you're saying that like every time maybe you want to make polycube or something like that. That means that Maya knows that I'm trying to draw this command polycube from maya.cmds. It's like a background thing, but I don't honestly really know how it works too much, but basically you want to write that at the very beginning of most scripts that you make in Maya, at least in Python anyways. Okay, so let's say that we want to make a joint on the cluster. So we're going to get a selection of joints. So let's make a variable called mySelection, which is going to equal the list of my selection, which is true. So if I were to click on this, and let's print out my selection. Let's make this bigger too so I can see it. So right here, I'm going to select this edge loop, right? And I'm going to run this script, and it'll say that it has all these vertexes, right? But here's the problem. You want to be able to get every single vertex in one separate list. And the way to do that is in this command, you actually have to have another flag called flatten, which is FL. So now when I print out this thing, right, it's going to get this list of all the different vertexes that we have, and that's exactly what we want because we can do stuff to these individual pieces of the list that we have. So we don't need to print this anymore. So now we have to figure out where we're going to be putting so we have to make the cluster, right? So we can do cmds cluster, and that will make a cluster on wherever we have selected, right? If I just run that. So, whoops. So now, and let's name that cluster. So the cluster is going to be, I don't know, dumb cluster. Dumb clubber, sure. Why not? Okay, so let's query the position of the cluster. So, and that's going to be clus, or I guess let's call it club because it's a dumb clubber. Club pos or position equals cmds xform. Xform we're going to be. I mean that should work, but I think what happens is that when you make a cluster and even when you call it something, it'll be called dumb cluster handle, and sometimes you might not want that. So instead of naming it, let's just call it a variable. So let's make this dumb clubber equals, just name it correctly. How about that? Stupid. Dumb cluster equals the cluster, right? So I'm going to xform my dumb cluster. My query equals true. Whoops. Let me just move this over so you can see it. And we're going to get the transform equals true. Let's see if that works. So delete this. So if I have all these vertexes selected, I'm going to make this, and then I want to print out the cluster position. So print club plus. Okay, go. Well, that's interesting. So it has 0, 0, and 0 as the transform, but Okay, let's see if world space is true, does anything. So I'm basically making so that the world space of this transform is true rather than its object space. So obviously it's going to be 0, 0, 0 if I do that. without the world space. So let's see if that works. Still 0. Okay. So how about instead of doing the transform or the world space, what if we do the rotation pivot? RP equals true. See if that works. So I have these vertexes, and I'm going to query the position of the rotation pivot point of the cluster when it gets created. There we go. That's exactly what we want. So we have this is basically 0. I know it's a bunch of numbers, but it's basically just like 0 to the power of, or sorry, 0 with 8 decimal points and then this. So that's like, it's basically as close to 0 as it can get. 0.57 in the y, and then this is basically 0 as well. And if we check, okay, so let's say that I want to make a cube and I want to put it right on the cluster. See, it'll say 0.058, which is exactly this right here, which is what we want. Okay, perfect. So let's delete these clusters. So that's exactly what we want. So the cluster position, let's say clus position, is exactly where we want the joint to be. Yeah. So now we're going to make a joint using the cluster position. So we're going to create a joint and we're going to put it in the cluster. So we can say CMDS joint, my joint equals that, and then we can CMDS x4. Actually, let's do this in one line. We can actually do this in one line. So CMDS x form, and then inside this x form, we're going to create a joint. So CMDS joint, and the transform is going to be the cluster position. And let's just say world space equals true, just to make sure that it's in the right world space. I'm not sure if we'd actually need that, but let's just, better safe than sorry, I guess, in this case. And then we're going to, okay, so it's going to create the cluster. Then it's going to move the joint underneath the cluster. But when it gets created, this cluster is selected, so it's probably going to create it and then parent it. And we don't really want that because we want to delete the cluster afterwards, right? So yeah, that's what happens. So I mean, it works. If you turn on the X-ray joints, you can see that it's created where we want it to go. But the joint is parented underneath the cluster. So we have to unparent the joint and then delete the cluster. So let's delete this stuff. What is that? CMDS parent? I don't think there's an unparent. You just have to make the parent the world equals true. So, okay, we create the cluster. What was that? We create the cluster. The cluster is selected. We create the joint. The joint is selected. So now, since the joint is still selected, we're going to unparent the joint by making it the parent of the world rather than the parent of the cluster. Yeah, that makes sense. Okay, and then CMDS delete, and then we're going to dum cluster. So if this should work, I'm going to I'm going to select a bunch of vertexes. I'm going to make a cluster in the middle of all the vertexes. We're going to query the rotation pivot point of the cluster. I'm now going to make a joint and put it in the transform of that rotation point of the cluster we just made. We're going to unparent the joint and then delete the cluster. So if this works, that'll be amazing. Let's see if this works. Cool. So that totally works. Awesome. Let's see. Yeah, so that's 9 minutes. I will leave it at that. Let's do another one in another video.